thank you for your patience for being here at this late hour and for the last session of today's Typo 3Con. My name is Frank Feulner. I'm heading the software branch of a local company called aexea, so sorry for my terrible English. And I am here to tell you today about the topic making data talk. Who am I to tell you, probably some of the best developers in the world, about how to design your databases for lingual applications? I take this audacity just because I have seen many databases fail or succeed in linguistic applications because, guess what, I make linguistic applications with aexea. To sum this topic up in a short manner, since 2009 we've been developing a software which is capable of analyzing structured data, building up an opinion about the kind of data it is taken up, and formulating this opinion and expressing this opinion in actual speech. It has gotten as far as writing promotional texts for TV sets, but it's a beginning, I guess. If somebody would call out the buzzword semantic, guess what, I wouldn't deny. So, is there any good reason to actually make text from data? What you see here seems like a big promise. I promise you that it's going to be cheap and fast and reliable. Which means after an initial setup phase, after the programming is done, you're probably not going to worry a bit about how the texts are going to come out, about how to scale, about how to produce texts in tremendous amounts, because machines don't forget anything you teach them once. Machines don't forget briefings. Machines don't sleep. It's already available while you hack your data set for example, the newest iPhone together, and it's ready to produce a text at any time you want. Seems great, doesn't it? So, the advantages in the long run are that you clearly save time and money, and that you can scale. Seems fancy in theory, but it's fancy in practice as well. Like, for example, if you build up a business case over 3 years for replacing your copywriters for, let's say, an online shop, for, let's say, consumer electronics, with this machine, you might probably end up at a lower cost per text with extremely high output, and you will lose no sweat about text quality or about text availability after the setup phase. So, while I'm starting to sound like a real salesman, sorry for that, there's of course advantages for the customer too, because customers and Google and pretty much everybody else likes meaningful content. What do I mean by meaningful content? I mean that nobody wants to hear gibberish, nobody wants to be disoriented, everybody wants to clearly know this text is trying to describe something to me, this text is trying to tell me something, I know what it's trying to tell me, and I understand the text. That's a really important one. If you ask your customers for their experiences with, for example, text spinning or crowdsourcing or all those other low-cost, high-scale solutions for generating content which are around, you're probably not going to get the brightest resonance, because content may be cheaply produced, content may be poorly produced, it may not follow standards, and it may cause a certain degree of desorientation while reading it. Customers may ask, what are you trying to tell me with that content? And if you, in contrast to that, ask them what kinds of texts really convinced them into buying something in the past year, they will probably answer that it was those texts that really informed them. It was those texts about which they could say, okay, now I really know more. And furthermore, I know that I'm the guy this thing has been made of and I gotta have one. That's probably how texts in an e-commerce context may work. So the value I'm promising with this software solution, and I promise this is going to be the last bit of sales, is that you add for your customers a bit of knowledge and valuable conclusions to the content you are presenting them. Yeah, and okay, /sales, this is where semantics comes into play. And on this sheet I have tried to sum up how a linguistic application may work, at least how mine does. Basically it consists of 3 parts, of 3 big tasks. The one is reading data, another one of which is drawing conclusions, putting logic, putting structure into the data, and the really important one is expressing these thoughts into actual language. Why is it a problem to express something into language, you might ask? You have a basic information which is lying there as a Boolean value. You know there is, for example, a mouse inside a PC set. You have a syntactic structure, like for example, Peter has a or Peter has two, and you would have to say mice. Who teaches the machine that mouse forms into mice when combined with two? And that's the part where a linguistic application really starts putting in value. Of course, it's not the only task of my machine to know when to say mouse and when to say mice. There is also the possibility of inferring something out of a certain data construct, like for example, is it appropriate in this text to say rodent instead of mouse? Or should it rather be human interface device, for example? Or if you if you put the mouse into a more complex structure, like for example, if you add an adjective and an article, is it necessary to say a mouse, or should we differentiate and say an educated mouse? That's all the fine works, that's all the crafts works that a sophisticated linguistic application should really do. So what we should remember is, a machine may be sophisticated, but it's far from all-knowing. There's a really, really bad trick about those machines, and it's that they act in a Rain Man kind of way. What you input basically comes out unreflected unless you program something to modify it. So what the quality of the output of this machine depends, of any machine, depends on how well you treat it in the first place. It will show absolutely no mercy in speaking out all the gibberish we have put into it in the first place. And that is why I've prepared some tips how to maintain data to make it suitable for linguistic applications. Basically, all the experience, or the most important experience I have gathered in my working with databases for linguistic applications can be summed up in 6 tips, 6 hints, of which the first one is keep in mind that it's language. So we need to make clear that everything that you input into the machine is going to be spelled out in some kind of way. In these 3 examples, it's mostly inappropriate measures, inappropriate scales that have been chosen, like for example, who in all the world is going to identify with an age group like the 91 to 99-year-old people? Is there any good reason why this product wouldn't work for an 89-year-old, for example? In this case, the scale doesn't make sense. In the battery case, for example, it's not going to work out for your customers if you tell them that their battery is going to last for a battery lifetime of 15 volts or of a certain amount of milliampere, for example. So what I'm trying to tell you is that the first step in designing a database that is supposed to speak at a later point of time is to make sure that it contains the right information, that it contains speakable information. So this is the part where I'm trying to be funny, so it's going to get really bad now. When I say don't be irrelevant, somebody should laugh now. When I say don't be irrelevant, I mean that it's not necessarily necessary to drag along information that is not going to be put into a sales text at any point of time. I mean, this is all legitimate information. You can input into a database that there's a brown cardboard hull, or that this product is about 66 pounds heavy when being shipped, while not being able to be shipped, while not having 3D playback, and while not having an HDMI interface. But does it really make sense? Does anybody want to know? I say no. I say that you should really focus on the data you really want to talk about, and in turn omit the data which is not speakable, which is not of any use for the customer, unless there is any other use, like for example a tag search or some kind of filter which this data could be used for, like for example filter all the articles that can't be shipped, or I don't want to buy a heavy TV set, give me a light one. But data selection is a really, really central issue when you start designing a database that is supposed to speak. It's also important that the data you're keeping has a meaning, that it has a point. Once a customer, for example, gave me a sample of a database to make text out of, and when he saw the first sample text, he saw that we had used some kind of weight data field to express something like, this jacket is really lightweight because it weighs only 900 grams. Guess what the customer said? Hey guys, please don't use this field about the weight because it's always 900 grams. Nobody knew where the information came from, but every time that a data set was generated, that a new article was set up, this field was generated, and from this point in time it started costing, and it was of perfectly no use for anybody. So don't do that. Speaking of data architecture, if you invest the time and the money and the skills to build a data architecture for your product, it might be good advice to really use it. This is also a customer example of a database for consumer electronics, where the customer had paid an agency to make up a really sophisticated design of about 600 data fields. It was multi-level, it was XML, it had everything, and the people who filled it did this. They filled 2 fields, and what was semantically left for my machine to render was, it was an Intel CPU with a pretty fancy name. Does anybody see the irony in this? All the information is there. We have outstanding performance, we have an Intel Core i3, we have the serial number, we have the amount of cache, we have the amount of cores. That's all sales data, that's all sales relevant. But the machine can use none of it because it's poorly assigned. So I guess the clue I should give you at this point is stick to data architecture. Fun fact about that, it's a problem that is perfectly not going to pop up if you use this data for publishing. If you, for example, make a list on your website, on the article site, on the article page, with a point CPU, nobody's going to notice that this data is poorly assigned. But as soon as semantics comes into play, it's certainly going to be an issue. Can anybody guess what I mean by throw some D's at it? A thing that is not clear to everybody I have been working with, but to at least some people, is that data won't come for free. If you want your data to pay at some point of time, you got to pay it first. And that means pay for qualification. Put people on the job that know what they're doing, and in the ideal case, let them know why they are doing, what goals they are following. Pay for a proper infrastructure. Give them suitable tools to maintain, to check upon, to export the data, to make sure they can properly work with it. And if you don't have the knowledge of how to properly build a database in-house, for hell's sake, go buy it. There's enough consultants out there who know how to build a database, and they will gladly help you. And I promise you it's going to pay by having a much improved data quality. And if you think of outsourcing, make sure you pay for the proper service level. What I'm trying to say is I'm not trying to sell you anything, I'm trying to raise some awareness for that building a database is a proper project. A project which needs to be assigned resources and time and goals, etc., in order to work out. You may ask yourself why I'm getting so frenetic about this. It's programmers like me that have to deal with the poor data quality that students or interns or whoever have created in the first place. And for the future of linguistic applications, I want to make this practice a little better. I want to raise awareness for how important data actually is, good data. Speaking of infrastructure, it may be really helpful to have your automation fed by automation. I don't know if any of you has ever thought about what impact the use of a radio button or a checkbox or a drop-down menu may have on the consistency of your data. Anyone? Anyone knows what I'm talking about? Okay. The assumption that structure or automation is important for the consistency of data can be easily put to the test. Like, for example, let's say you have a database, you put up a field for the manufacturer name, and you have people fill it. I'm going to take bets on how many Samsungs you can fill in until somebody writes Sam's gun. And I'll be taking also some bets on how many L's you can put into the manufacturer name Philips. My personal best is 3, and it was not exactly easy to explain to my customer why I write Philips with 3 L's. Well, from my point of view it was. I said, you wrote Philips with 3 L's, but that's usually stuff customers don't want to hear. And I will also take bets on when the first person is going to pop up with a question like, is it really necessary that we write all the manufacturer names in capitals? And you'll be like, what do we, really? Yeah. So the advice I can give you on this one is use structures for input to get structured output. It's tremendous what a radio button can do just by limiting the possibilities of choice. If you have a drop-down menu that says Samsung and Philips, nobody's ever going to write, nobody is even able to write Sam's gun or Philips, as in my case. I even have a keen hypothesis about this. I would even say that all the data that concerns a product category and is not specific about the product itself can be expressed by predefining some kind of multi-selection. Nobody will ever need a text or a string input, a text box for expressing something about a product category. So if any of you is involved into e-commerce, I strongly recommend that you kill all the text boxes you can find. So, having heard all this advice and having done all the homework, your data may be at this point well shaped, and it may be also speakable, and if you're lucky, even your data maintenance process is good and is fluent. But before you start actually doing something with your data, before you actually start cashing in on it and using it for any kind of application, this might be the perfect moment to take a step back and ask yourself, is it really still logical what I have put into the database? Of course you will say, I know the last thing about hotels, of course my hotel database is consistent. And I say probably not. This is an example from a customer database which was built up in an XML format and which was pretty multi-level. And we had a node which expressed the room equipment features, and it had a sub-node which expressed coffee machine. And somebody went on and gave this coffee machine node a child called malfunctioning pointer, called toaster, and to this toaster clung another node called water boiler. Does anybody have a hint what might happen if you fill in a water boiler? A toaster magically appears. And in the long run, a customer steps into my office and says, hey, why does your machine keep texting about toasters that aren't there? What's your thing with those toasters? Another example is also from a tourist context. It's the even more magical pool. That's how I like to call this one. You have a text box, yeah, a text box for the number of pools. Anybody can input any value into it without any relation to the further data which is input into here. So what can happen? Somebody says, this hotel has 1 pool, 2 of which have at the same time salt and fresh water, and are at the same time inside and outside. What you get there is data mud, data, I don't know, a data artifact. And that is something you should probably not do. What you should really do is check dependencies within the data and really take this step back and check if the data you have produced is still logical. A good test may be just to spell it out loud, to say it out loud, to see if it makes sense when it hits your ears. Guess this one probably won't. And if you follow those steps, if you really invest the time and the commitment into the quality and the structure and the logic of your data, what you might get at the end is something like this. This is a text one of our machines wrote out of a German data set, and it describes why anybody would want to visit Innsbruck in the German Alps. I guess this is a good point to let this linger for a second. And what you see in this text is that it's really not gibberish, it's really filled with meaningful information. You have something like a well-formed city name, you have something like evaluations about what Innsbruck is made out of what you can do there and the count of events you find there. The countless leisures, that's also a dynamic element. There's a huge potential of really tailoring a text along what data you put into it, for really letting this machine, this cute little fella, know what you want to tell your customer. And this is the promise I make for you if you promise to keep a little eye out for the quality and the sense your data makes. If there is still anyone in the audience I haven't lost yet, you can follow me on Twitter at Frank Feulner, or you might want to visit our global website, aexea-global.com. Is it F5? It's aexea-global.com or aexea.de. And this might be the perfect point to stop getting on your nerves, thanking you for the attention and wishing you all a nice evening. If there's any questions, I'll be around for a few minutes, so thanks.